Welcome to RTools MAXX, Mersen's free online simulation software that allows you to select a heatsink solution tailored to your application. This tutorial will focus on creating a Mersen AquaSurf design. We will start by signing in to begin finding the heatsink you need. Create your account by putting in the email and password you would like to use with your new RTools account. Click Agree and sign up, and an email will be sent to your inbox shortly with the links and steps to validate your account. Once you are signed in, you will see the project screen, which will show all of your RTools projects. You can see the status of your projects, its details, and edit, copy, or delete them as needed. To start a new project, click the orange New Project button to begin. You can return to your project menu anytime by clicking the Projects button. You start a new project by putting in your project name. You can enter any notes in the description box, and then you select between the mechanically bonded fin, extrusion, or AquaSurf, our tube-embedded cold plate option for liquid-cooled projects. We will be walking through the design process for an AquaSurf. Then, you will select your preferred units and create your project. The first step is to put in your boundary conditions. Input the ambient temperature surrounding your cold plate. Here, you can define the cold plate base plate volume available for your project. You may specify the width, length, and thickness of your base plate. These dimensions do not include pipe headers, which can extend above and below the length of the base plate. Please account for space for headers in your system when determining your base plate volume. You may reach out to an engineer for support in the added volume this is projected to require, but header design will largely depend on design details for flow rate, series or parallel design, and other factors. Here, you define the maximum cold plate base plate temperature allowed for your project. If your boundary conditions lie outside of the minimum and maximum inputs allowed by RTools, please contact the engineer team for your region through the Help button to look into a custom solution for your project. All inputs are saved automatically. Even if you close your tab, you can come back to see all your parameters as you set them. On to the Pipe Configuration tab. Here, you specify boundary conditions for the pipe and fluid. To start, please input the input fluid temperature of the fluid entering the cold plate, the flow rate of this fluid, and the max allowable pressure drop for the cold plate. Here, you may select the tube outer diameter and its embedded position in relation to your heat sources. Tube outer diameter will influence minimum base plate thickness, so please make corrections as prompted to your base plate dimensions on the previous tab. You may specify the tube material between copper and stainless steel options and select fluid type for your cold plate. Based on standard material and fluid compatibility guidelines, fluid selection is limited based on material selection. Moving on to the Source Layout tab, you may place 2D representations of your heat sources on the base plate dimensions you input on the Boundary Conditions page. You add a heat source by clicking the plus icon. Hovering and selecting the pencil icon in the top right corner of your heat source, you can name the heat source as well as define the power, size, and placement. You may also drag your heat source to the location you need. Rotate, copy, center, or delete. You can adjust your view of the layout with zoom, or turn on snap to grid and adjust the size of the grid to assist in placing your heat sources on your heatsink. With snap to grid, the corner of your heat sources will automatically align to the closest grid. If your placed heat sources overlap, your estimated and simulated performance will be incorrect. Please ensure your heat sources are placed properly. On the Pipe Layout tab, you may place 2D representations of your pipes on the baseplate dimensions you input on the Boundary Conditions page, under the heat sources you placed on the Source Layout page. You add a pipe by clicking the plus icon. Hovering and selecting the pencil icon at the top of your pipe, you can define the pipe's placement in the X direction, or you can drag and drop similar to how you did on the Source Layout tab. If your placed pipes overlap or are too close together, your estimated and simulated performance will be incorrect. Tube outer diameter will also limit minimum pipe spacing, so please keep this in mind when designing your cold plate. There are two configuration options between parallel and serpentine, which will change the fluid flow path. Similarly to the previous page, you can adjust your view of the layout with Zoom, or turn on Snap to Grid and adjust the size of the grid to assist in placing your pipes on your base plate. With Snap to Grid, the corner of your pipes will automatically align to the closest grid. Moving to the Solution page, the Summary tab gives an overview of your project parameters. If the parameters look good, click Run Simulation to begin running the solution. Even if you close out of the tab, the simulation will continue to run. Once the simulation is complete, the solution message will give recommendations based on how well the design meets your thermal requirements. If the simulation results are acceptable and within your project MAXX parameters, you can export a PDF report of RTOOL's MAXX results, as well as download a QFIN or step file. You may go back to any previous tab to make adjustments to your design. However, any changes to the inputs will delete the current simulation result. If you would like to preserve the simulation result, you can go back to the project menu and copy the project. You can then make your changes on the copied file while preserving your previous results. When you are ready, these files can be sent to our engineering team with the Quote tab to receive a quote on your design. This concludes our tutorial on designing an AquaServe cold plate.